I think it's time to start now. So we can start now. Okay. Good afternoon. Welcome to join ZNShine Solar's webinar, Ushering in the Next Stage of Smart Energy. My name is Nicole Yang. I am the Marketing Director of ZNShine Solar. It's great to be here today and joined by the team members from Zheng Energy, TUV Suite, and the CSA Group. We will have 4 experts to share advanced insights and the knowledge about energy products and the smart energy system. We're going to hear from my colleague, Zheng, General Manager of Product and Technical Center at the ZNShine Solar, Vivian, General Manager of Business Development at Zheng Energy, Marco Frank, Section Manager of Energy Battery from TUV Suite, Great China, and Kyle Song, Operation Manager from CSA Group. Okay, hi, Eric, Vivian, Marco, and Kyle. Can you please quickly say hello to our audiences?
Hello, everyone.
Hello.
Hello, everyone.
Okay, Nicole, so it's time to...
Before we get started...
Okay, so I will start firstly.
Okay, before we get started here, I have a few highlights for our audiences. You may be joining ZNShine Solar's webinar for the first time. So if so, here are a few tips for you to get know as attendants. Feel free to send any questions you have through the webinar in the chat box, and we aim to answer your questions during the QA section at the end. And we are recording the webinar today, and we will let you know by emails where to find it and the slides deck, so you can re-watch it at your convenience. Okay, Eric, I will let you to control and share the slides.
Okay, I have finished the sharing of the screen. So, hello everyone, this is Eric. I'm in charge of the technical and products of ZNShine Solar. So today I will introduce our new solution, integrate PV ESCS system to all of you. So firstly, I want to explain what is PV ESCS. Everyone know what is PV. ES is the energy storage, and CS, it means the charging system. And totally, I have 5 main topics. At the beginning, I want to say something about the preface. There was a joke in the internet. The end of PV is the energy storage. But today, I just changed the words to the end of PV is PV ESCS system. And in this page, I just summarize 4 kinds of traditional application of the energy storage, such as the application in the generation side and the grid side, user side. And the function of the application, such as the energy storage, can absorb the extra PV and wind generation, and smooth the power reflectuation, and also can promote the reliability of the power generation. In the grid side, it also can prolong the updating of the old grid, and it can be the supplementary power supply. In the user side, it can can perform the peak load shifting, and also the most important thing is it can save the energy storage. And the PVES system can be used in the microgrid and isolated grid, especially for example some isolated island. The next I want to highlight the essence of this kind of integrated system. Actually, it could be the precise business calculation about the electricity. We can notice these 2 diagrams in this page. We can use the regulation of the different price in different period. So we can we can perform the charging process when the price is lower, and discharge when your machine require more power. So I mean, if you are the salesman or the system designer of the integrated system, you must make clear these four key points, such as the policy of time of use and the different types of the electricity price in the sales region, and also the types of the electrical load and the power demands and the regulation of your customer. So the third point is very important: the original power system configuration and the updating plan of your customer. And finally, we also need to teach the customer how to adjust the power requirements according to the production capacity due to the working days and the other stage. And this page just shows the circular liters philosophy of the energy storage system. We summarize three kinds of coupling types in the market. The traditional one is the AC coupling. It will use solar inverter and the PCS to connect the PV system and the energy storage to the grid. The disadvantage of this kind of coupling is it will require a new PCS and have four stages of the power conversion. So it have the lower efficiency. The next one is we call it DC coupling. It need to replace the old inverter to a new one. The new one is the hybrid inverter, and have better. This method will have better efficiency because it just have two-stage conversion. But the newest one in the market is we call PV coupling. It will connect the PV panels into the energy storage directly, and then connect to the old inverter. So if your customer wants to wants to update the energy storage in the old system, they don't need to add any components and have better efficiency, because the electricity seems to be conversed directly. But for this system, it is newest, so I thought we also need to do more evaluation about its reliability. In this page, I just summary some mine certificate for the integrated system. It includes some the product certification about the energy storage and the inverter and some grid connection. I thought today 2 experts from TVSUIT and the CSA will give some details explanation to you. So I just go through quickly. And in this page, I just summary 4 main kinds of integrated system. The first one is the backcoupled system. This system will be based on our flexible panels and the microinverter. And the second is the sunlight room, integrated sunlight room system. This system will be based on our special waterproof bracketing system, and also use the quick installation solution. The third is our mine system. We call the integrated residential system. It will be designed based on our SIS system for the residential rooftop. The last one is our special carport parking system. It will use our special carport bracket and the quick installation solution. First of all, I want to highlight our ZNShine standard rooftop solution. We call it SIS, just a brief introduction. So the vision of this system is simple, swift, and sturdy. In this system, we'll use all the standardized components such as the panel and the rear, and even the clamp. Clamp also is the very standard. We don't need we don't use the end clamp and mid clamp. All the clamp is the same. So all the purpose is we want to reduce the kinds of the components. All the system will be simple. So we use several combination based on the simple components, and to fulfill the requirements of the different rooftop. And then even the packaging or the package method also is standard. We designed the standard package for all the components, and load and pack all the components into the one container. So the highlights of SI system is the anti-loosen. We use a very special clip to finish the installation. As we know, for the common system, they will use the clamp. If you use the clamp, you will use the boards, and after some time, maybe half year, the torque of the boards will be reduced. But if you use the clip, they will know this kind of issue. So it means the maintenance about the torque. We don't need the maintenance about the torque. So it means the cost of the maintenance will be lower than the traditional system. And this page, I just summarize some 6 kind of residential system. We have 3 split top system. And also the next step, we also want to promote the AIO system. What it means the AIO all in one. It means it is an integrated machine. Usually for the off-grid market, the customer concern the cost efficiency. So it seems the split top machine will have a better price, a lower price. So for this system, we recommend the 2.5 kilowatt and 5 kilowatt and 10 kilowatt. We thought for the off-grid, usually the power requirements is lower, so we don't want to recommend some high power and even the 3-phase system. But the special one is we want to recommend the one AIO off-grid system. Why? Because everyone thought the off-grid system must will have the lower price. Why we promote the AIO? Usually everyone thought the AIO system will be used in the upscale market. But for why we promote the AIO off-grid system? Because the split top system maybe have some issues because it needs lots of connection between the different components. Maybe have some issues, and some customer they have less professional knowledge, so they just need the simple connection between the panels and their machine. So the AIO off-grid system will have simple connection, will reduce your cost before sales and after sales. And another tool is the traditional AIO system in the upscale market. It is usually off and on-grid system. So in one word, our ZNShine can customize the best combination of the inverter and the best and balanced with the consideration of the cost efficiency. Our engineer can customize the system as your requirements. Because in this PowerPoint, I just can summarize some traditional power. So the next is some details about the off-grid solution. You can see the standardized BOM list of all the system, and also the diagram of all the system. What is the off-grid? It means the power from the system, just from the system, cannot connect to the grid, but the any storage can charge the electricity from the grid. It means it cannot just one direction. And also you can notice that all the visual of the machine is very simple because we need to consider the cost efficiency. And we also recommend the inverter and the battery to do 1 to 2 configuration to use. And this one is the 5 kilowatt and 10 degree battery. And this one is the 8 kilowatt, 15 degree. But you also can notice that we also mark the EV charger. Usually for the off-grid system, the customer, they will not use the electricity car. So we just set this one EV charger as optional items. The next, I will show you some details about the AL top solution. The first one is off-grid, just which I mentioned to you. So it is very special. Usually the off-grid system is very hot in the South Asia and some Africa country. And you must know some customer in Asia, they also they also care the how to say the reliability of this whole system. So the off-grid, they require this kind of off-grid system. And the next is the AL system for the upscale market. It uses the 6 kilowatt, 10 degree battery. You can see the visual of the system. It looks nice because the unit price of this kind of components will be higher. And we also will use the meter to do the statistic of the electricity of the system, and also can prevent the reverse current from the grid. And the next one is another configuration. It is have more power, and this system will use the 3-phase hybrid inverter. And the next one is our some details of our balcony system. We also have 3 kinds of choosing. The first one will use the 800 watt micro inverter. The key points is this inverter also is a hybrid. The traditional one, traditional using is very simple, just the inverter and the flexible panels. As you know, for some, based on the special regulation of Germany market, the customer, they don't need to apply with government, and they can DIY the low power system by themselves. And the next one, we just add a small battery in this system. And the next, because someone is very strange, why you also call the balcony system as to be the CS. The balcony have no charge EV charger, right? But the charger is this. We use the mobile base. So you can imagine that you can in working days you don't need to use more electricity. but in weekend you can take away the mobile base, and you can cook the hot pot in the outside. Use this mobile base. So it will be very interesting. And the next is our parking system. We also have three kind of design. The first one is the design for the household. As you know, for the traditional home, they just have 2 cars. So we choose the 10 kilowatt and 20-degree battery, and use a common AC charger. As you know, the common AC charger, the charging speed is lower, but for the home using, it is enough. And the next one is for company. For company, we set up more carports, 12. But in this system, because we consider the cost, the system cost, so we also use the traditional EV charger. The speed is lower, but you can imagine that the employee from the company, from the factory, they have enough time to wait the charging progress. And in this system, we are used 100 kilowatt hours energy storage and 40 kilowatt solar inverter. And we choose the 585. This kind of panels have good cost efficiency. And the next for commercial, as you know, lots of customer, if you are a customer, you in the commercial carport, you must require the high speed charging. So in this system, we use the EV charger with more power, and also based on the consideration of the high speed, so we use more battery, 215 energy storage. But the key points of this carport is in this page. You can see all the components of the carport, I mean the bracket, also is the standardized design. And we also use the special installation method. For the common installation of the panels, usually they will use the clamp, right? So if the operator they want to install the panels, they need to clamp on the top of the panels. So it will be very complex, and also I thought maybe it is dangerous. But we use the special clip. The name of the clip is Shing. So the operator, they just need to install the panels behind the system. So it will be more quick, and also more safety, or more safe. And another special design, we are pack all the components of the whole system in one container. It means our customer, for example, in European, they can receive the whole system together. They don't need to select all the components from market, purchase from company A and company B, and it will be very complex. But if you use our system, it will be very simple. And the next, I want to highlight again the integrated packaging solution. So all the integrated system which I mentioned to you in the former page, we can design the integrate packaging solution. For example, in this page, we just packed the 5 kilowatt 10-degree system in 140 HQ container. So in this container, we can pack around 54 sets. And in this container, it is 8 kilowatt system. We can pack the 40 sets. this is almost the same for the high power system. So the sets is less. Okay, so I just finished my presentation about our integrated system. So if you have any question, you can leave the message in the Zoom. Okay, thank you.
Okay, thanks, Eric, for sharing the introduction about the integrated PV storage and the charging system. Now let's catch up the latest energy storage products and technologies with Vivian from ZNShine Energy. Welcome, Vivian. Oh, Vivian, sorry.
Hello, everyone. Thank you, Nicole, for giving this opportunity. So can you share me, see my screen? Nicole, can you see my screen?
Yes, we can see your screen.
Yes.
So
Okay.
maybe you need to present.
Yeah, I will put into the. Okay, and Eric just give introduction about the whole solution. So I will based on Eric, I would give some like the basic support to Eric's solution is the energy storage product. So today I would give you a little bit introduction about our company and also a very simple national about the certificate national requirement. Very simple one because I believe Marco and Carl will give a very detailed one, and the last and also the important part is about our products. Firstly, about our company is, we are ZNShine Energy, and on the ZNShine group, we have almost more than 28,000 people globally, and our key business cover the automobile, machinery, property, and finance. We are a pretty strong company, and ZNShine Energy we founded in 2017. And our key products, including like the clean energy product, like the gas power generator, gas turbine, and also including the renewable energy products, including the PV system solution and energy storage system solution. Also, beyond the hardware, and we also develop our EMS system to support the whole solution. And we use just the distributor to cover the whole global market. That's our global distributor layout so far. And a little bit introduction about the national requirement and the battery energy storage system, including the key ports is the battery battery and the PCS. So the certificate is about the BESS system and PCS and the battery. So beside the battery and beside the system, the battery itself, and also the battery and PCS have the safety EMC and the on-grade certificate requirement. Also, because the battery is dangerous good, so you also need all kinds of the UN 38.3 and MSDS and all kinds of this shipping document about the dangerous package. And basically, so for the North American, you will follow the UL certificate, and for Europe, you will follow the IEC certificate. China, we have our own certificate requirement, and Australia will be different. And Middle East, Africa, and Southeast Asia, most of area is don't have any certificate requirement, but still based on different projects maybe. So a very simple introduction about this. And about our products, and like what I said, and our renewable energy basically cover a very full page, including the residential to commercial to the containerized BESS system. Also, we have our own EMS. For the residential, we have the all-in-one design. We call it RPI plus B, and we also have the system for the off-grid low-cost one. So for the commercial, we have the all-in-one design, including our CP50, CP100, and CP200. This is all air cooling system. Also, our most popular one is the CP200 liquid system. It's also all-in-one design. And all this is actually the all-in-one design and suitable for the low wattage connected with grid. For the project base, we have the CP100 for the liquid cabinet. It's DC side, and using a more bigger battery. So we also have the CP400. And of course, for the containerized cabinet, and we also have our own products. So today I will give you a more introduction about the residential and the commercial one. For the RPI plus B, and Eric mentioned a little bit about this, and so this is our most, I would say, most advanced product in the market. And we offer the single phase ESS and the three phase. Single phase, we have 3.6, and which is normally popular in like the UK market. And but basically, the most popular one is the 6 kilowatt inverter. And the battery, we use the battery pack is the 4.8 kilowatt hours. So for one single inverter, you can connect it 1 to 4 pieces battery pack. For three-phase system, we offer 8, 10, 12, these three inverter, and it's share the same battery pack with the single phase inverter together, but the three-phase inverter can match with 1 to 6 pieces. And I would like to give you a more detailed introduction about the very good performance about this system. This system actually we call it a 4-in-1 system because it's not only include the battery. It also have a hybrid inverter integrated, and also have the on-off grid switchable capability, and also have our own EMS. This system actually can give you a seamless energy switcher. So the typical transfer time is less than 10 milliseconds. And for our system, normally in the market now, the most popular one for the residential is the PV input is about 1.5 times, but our system accepts 2 times the PV input, which means for one single system or one single inverter, we can accept more PV panel. And easy expansion. Give you an example for the easy expansion, like for people, because for this one it's really not very low cost, a little bit high cost because the high technology. When people are hesitant to making the investment, maybe they just want to buy 1 unit battery to try first to see the performance and see if they can use. And maybe after installation, they feel the performance is good. And maybe if the home buy more electric equipment, they need more battery. So they can easily buy one more battery from distributor and connect it to the whole system. Don't need to doing any like the self calibration to charging that battery, and until the battery will be same level with existing battery. We call it like the avoid any cask infection. And our design for this is IP65, so it could be used indoor and outdoor environment. And for our system also, we call it higher profit from, actually it's in 2 points. 1 point is this system actually is a high wattage system. So the efficiency is 90%, comparing the low wattage one is only maybe about 80%, saving a lot of money for customer. And another one is even at night when a lot of the electronics are going to like the sleepy time, but it still consume minus electricity with a lot of other equipment, and maybe because the system cannot diagnose that there's very small electricity using. So those kind of equipment still use the electricity from the grid state. But for our equipment, so we can notice the very light load during the night. So the battery still can power the very light load at night. And this page will show you the place for the RPI plus B application. So this is a fully CE certificate product. For the 6K means the single phase, and 10K means the 3 phase. So you can see we have all the IEC certificate and EMC. Also for the grid certificate, we have the EN 50548, and Germany, Italy, Austria, France. So actually, I would say you can sell this product in the whole Europe and South Africa for the single phase. And so the second product I would like to give you introduction about is about the low wattage system. So including the battery and also the inverter. So this is the low wattage battery system, and comparing the high wattage, of course, efficiency is a little bit low, but the cost is really very attractive. So this kind of product will be really popular in the Southeast Asia and Africa. Those kind of area is like the utility is not very stable, or even totally off grid, no utility. So we offer 3 kind of the product. First one, we call it rack mounted battery. So the battery pack normally is 5.12 kilowatt hours. Very, you can see from the page, very easy installation and wiring and stackable. And we also offer the wall mounted. So maybe people who like to hang on the products on the wall, and of course this based on they need to get a very durable and strong wall at home. And also we offer the vertical battery, and it's for vertical battery we have the 5, 10, and 15 kilowatt hours in one complete product. So for the 15 kilowatt hours, the product will including the wheel. For 5 and 10, it's don't need. And so for different application and different using habit, we offer different solution. And all the products have the more than 60,000 cycle time. And this is the inverter we offer with the low wattage system. So this inverter must be, compatible with our low wattage battery. We strongly recommend to buy the battery and inverter together. So we also have the single phase, and we have the three phase. For single phase, we have the wall mounted, and also the stack rack mounted one to just perfectly fit with the recommended battery. And I will highlight the 5.5 kilowatt, the single phase inverter is that this one could parallel from 1 to 3 units. That means even at your home, you can buy one 5.5 or buy three as an installer or distributor. You don't need to stock. You just need to stock one type of the inverter. You don't need to have too much inventory for the inverter. This one is can offer you like 5, 10, 15 kilowatt with one single unit. And for the CPU series, I would just using the I just give you a very quick introduction. And so our system basically is including basically is the all-in-one design and DC side both. So the application scenario actually for the battery system can offer like a peak carting and valley filling. EPS function also is very good for like the East Europe and some area like in Ireland to access with the new energy. Also, you can use easily in the couple like what Eric said, the PV EV charge station. And of course, and the pure off-grid operation, we also can have this function. And taking our CP200 liquid as example, I just give you a more detailed introduction about the key components. From the left side, you can see the system including the battery pack here, 5 battery pack. And this is the, we call it PDO, the high voltage control box. And the whole system, including the firefighting system, use the aerosol. And so the right part is a liquid cooling unit, use the electric chipper. And the PCS is integrated all in this cabinet. So from the door, you have a touch screen, can adjust the application scenario. And for emergency, have an emergency stop button. So this is all the key components here. And for this one unit, the power is 100 kilowatt, but the capacity is 215 kilowatt hours. And we have our own EMS system to help the customer to manage the whole system. If you want to integrate with the PV, or maybe you want to integrate with your EV charge station, and our EMS system will set up the strategy for you, and you can monitor your whole system through the cloud platform or in your computer. And this single unit could be paralleled easily to be from 1 to 10 units in the grid connection model. Yeah, like this, very easy. And you can see in the top is the lifting lug, and at the bottom actually also have the forklift space to very easy to move. And beside the CP200, we have the CP100. For this system, I will highlight is the whole battery system is 1C battery system. It's an all-in-one product. We can do the solar energy, like the solar energy all-in-one. That means we can do both DC coupling and AC coupling. And so I will skip this because I already gave the detail. And for the a little bit introduction about the CP300 is the DC side only. So different, you can see different from the CP200. There's no PCS. So inside it just look like this. For this one, it will be like project based. So we can help you to design the whole project. So the DC, the DC side only, the cabinet will be used in some place like the capacity is over 2 megawatt hours. So below 2 megawatt hours, we would suggest to use the CP200 liquid, that one. This one will together will use together with like the PCS and the step-up transformer like this one to design the whole system. So key point is the single point connection over 2 megawatt hours and also the high voltage connector to this utility. We'll use this one. And finally, I will give you an introduction about the certificate status of our CP100 and CP200, these two all-in-one products. You can see we already got the all the certificate about the safety and EMC, and also for the state grade connection. We have the Germany VDE 4100, and also we have the Italy one. We have Australian and for Australian one, and we also have the UK certificate for the CP100. So for this product, we will suggest to selling in the Europe market that could including like Germany, Italy, UK, and also the Eastern Europe, because beside the Poland, Eastern Europe follow the EN 50549. Of course, for Southeast Asia and Middle East and Africa, we have the non-CE standard products. But we so it's a little bit different, and some key components may be different, but the battery will be the same, but just without the CE certificate, and of course the cost will be much more attractive. So this is all from my side.
Okay, thanks, Vivian, to introduce ZNShine Energy and the diversified battery products. Now we will have Marco to share the navigating certification for battery system in Europe. Welcome, Marco.
Hello. Thank you very much and welcome to this session. So now we learned a lot about the product itself, and now we go on with the certification requirements and other requirements like regulatory requirements for battery systems if you want to enter the European market. My name is Marco Frank. I'm engineer by passion and section manager ESS battery certification and testing at TÜV Süd, Greater China. I come with more than 7 years of experience in EV and ESS battery testing, and with specialized knowledge in safety testing, especially for thermal runaway, thermal propagation, and gas analysis of battery systems, for example. In my previous experience, I was working as an R&D engineer, mechatronics technician, and graduated from University of Applied Science in Munich with an electrical engineering, electromobility degree. Let's have a look at the agenda. We will go through the importance of CE marking for batteries, so especially for Europe, regulatory insights for energy storage systems, and safety tests under the battery regulation, and a further deep dive into IEC 62619 safety tests. When we look at the CE requirements to Europe, we see that the battery regulation is in force since August 2024, and especially requires comprehensive safety testing and also performance durability. It is required for every battery to confirm with these requirements for Europe, and by applying the CE mark, you show as manufacturer, or also when you place the battery on the market, so also as buyer and placing it on the market in Europe, you have to comply with these requirements, and with the CE logo, you show that your product is comply with all these requirements. CE mark, what is the meaning? It means that we have that the product fulfills health and safety directives for the market access in Europe. It is mandatory for all products entering the European market to show these compliance. Not to be confused with a quality label, it is related to regulations and requirements. Let's have a look into the regulatory insights for energy storage systems. So as mentioned before, we have the battery regulation, which is in force since August this year, and especially safety is required already. There are comprehensive safety tests described in the battery regulation, which has to be performed on the product, and also performance durability for energy storage systems above 2 kilowatt hours. For these systems, also the low voltage directive applies with a voltage rating between 75 and 1500 volt DC or 50 to 1000 volt AC, as well as the electromagnetic compatibility directive and the radio equipment directive in case the product comes with wireless technology. If this is not the case, then we look at the EMC directive. What does it mean in terms of testing and standards? You will see here some examples of test standards that apply and the product should have already undergo if it comes on the market in Europe. For the battery regulation, there are no harmonized standards published yet, still a very new regulation, but it describes in detail what kind of tests should be done. But we still have to refer to existing standards such as 62619 to know what kind of tests has to be performed. For low voltage directive, the IEC 62477 is a typical one which applies for energy storage systems, or another one is 62040 for uninterruptible power supplies. Then for EMC directive and the radio equipment directives, there are several EN standards, which a colleague of mine would for sure be able to explain in more detail if you have questions towards that. Let's have a look into the safety tests under the battery regulation. So this gives comprehensive safety above the battery product, starting from thermal cycling from very low temperatures to high temperatures, over short circuit test, deep discharge, thermal abuse test, fire test, and so on. But we see now that these tests are not covered in one single standard. So there's no single standard which is covering all these items. There are UN 38.3, which is required for transportation anyway, which covers some. IEC 62619 is a typical safety standard and certification, which is conducted for batteries for general safety, as well as the IEC 63056 for the battery system. But it is not all of that covered. I will explain a little bit more about this in the end. Now we have a look into the IEC 62619 testing standard. If the battery product has the certificate for this standard, what kind of tests did the product undergo, and according to or to which tests or scenarios the product is safe? Let's have a look into 62619. So here I use as example battery cell. For the short circuit test, we have a condition where we put a battery cell at a fully charged state under short circuit. It means if a very low resistance of 30 milliohm, connect plus and minus together and also remain this for 6 hours. this is to check what will happen on the battery. The requirement is to have no fire or no explosion. Typically, this is also can be passed, like prismatic cells often have internal safety measures inside, which prevents any heavier effects. Impact test for battery cell is also mentioned here, where the battery cell under 50% SOC will be tested. We have a steel rod put on the battery cell. We use a prismatic cell here, which looks like this. Here, just a small example. Now we have that also in larger form, can also be a round cell or pouch cell, but in this example, we work with a prismatic cell. So the steel rod will be placed on the battery. Then there is a weight of 9 kilograms, which is placed at 600 millimeter above, dropped down to have this kind of impact on the battery cell. Also here, the requirement is no fire and no explosion. Drop test. So now here the battery is not placed on the ground. The battery is actually on a height. Here depends on the weight of the cell, how the test is performed. For battery cells less than 7 kilograms, the battery will be dropped from 1 meter height down in random directions. So to simulate when the battery is transported or when it's working in the manufacturing process, if the battery cell drops down, what will happen? Also here, the requirement is to have no fire and no explosion at a fully charged battery cell. Thermal abuse test, that is to evaluate the battery cell at high temperatures. So here the battery will be placed also at a fully charged state in a temperature chamber and then heat up to 85 degrees, where it remains for 3 hours. And also here the acceptance criteria is no fire, no explosion. Overcharge test. So this is a realistic scenario, especially if the cell is in a battery system and there's a malfunction on the BMS, on the battery system in general, and the battery cell gets overcharged. So what can happen in worst case? We should evaluate how high the battery can be overcharged in this situation and then also simulate that in the test. If this is not the case, we can use 120% SOC, for example, as a reference and overcharge the battery. So also here, the requirement is to have no fire and no explosion in such a case. We look then also at the forced discharge test. Why forced discharged? So that means over discharged, in other words. That can happen if the battery cell gets mounted wrongly in a battery module or system. So when there's a manufacturing process, for example, it gets placed all the time in the same direction, and there's always plus here, or it is plus minus in reverse. But if there's one cell mistakenly swapped, maybe the BMS can detect it and it doesn't even start, or maybe not. So in case not, then it can happen that there is a forced discharge applied with the reverse connection, and there is a deep discharge on the battery cell. So this is why we do such a test, and we do this with 1C up to 90 minutes and also monitor the conditions of the battery cell during this test. And the acceptance criteria is also here, no fire and no explosion. Then we have the internal short circuit test, where we place a small nickel particle inside the battery cell. So here the battery cell gets opened manually. Why do we do this test? This can also happen during the manufacturing process when the cell winding gets produced in the factory. It can happen that a particle falls into the winding, and this is not recognized during the production process, and in the end it comes out as a finished and final product. Maybe also the first few cycles has no impact, but later on it can cause a short circuit between anode and cathode, which is caused or called an internal short circuit. So we simulate this in this test. We manually open the cell, put the particle inside, close the cell at the fully charged cell, and then put it into a chamber, which you can see here on this slide, and compress the cell to actively damage the separator and cause a short circuit between anode and cathode. then to check what will happen. How does the battery react? And also here, the requirement is no fire. Another abusive test is the propagation test, which is performed on a battery system. Here, a fully charged battery system will be prepared with a special cell. Like here in this example, we prepare a fully charged cell with a film heater, place it into a module, the module in the battery system, and then actively overheat the battery to cause a thermal runaway of one single cell. And this test is then to evaluate if there is a propagation from one cell to another, or even from one module to another, if the whole battery system will propagate, will it cause fire or not? Yeah, the aim is to stay safe. Like ideally, there is no propagation at all, or if there is a propagation, that it stays at least within module design, and in best case, there is no fire or no external fire. So the acceptance criteria here is no external fire, no case rupture of the battery system. Good. This was a very quick overview of IEC 62619 safety tests. And now we see that we covered most of the safety tests from the battery regulation, but some items remain open as the thermal shock and cycling, but this would be covered in UN 38.3. We could take this as an example, but the fire tests and gas emission tests so far not mentioned in an IEC standard. So how to do this test? Here we can refer for the fire test, for example, to UL 1973. We have one test mentioned here, which is so-called projectile test. We put the battery cell onto a flame and then really expose it to a flame, to a fire, and see what is happening. And gas emission, this can be done with an FTIR to analyze toxic gases, or also by GC to analyze flammable gases. So this just as example. Good. Then I would like to summarize this presentation shortly with a conclusion and give you some key takeaways. We see here the CE marking requirements for all batteries, and Nicole, and which is, sorry for that. Yeah, so CE marking is required for all batteries. Please take care when you buy the battery. I think here with the partners we are presenting today, they are well aware of that. But also when you place the battery on the market in general, make sure CE mark is on the battery, and also it complies with the regulations such as the battery regulation, the low voltage directive, electromagnetic compatibility directive, radio equipment directive, and so on. So this is just a short insight into the key requirements, but we are more than happy to help you with entering to European market. If you have any questions, let me know. As TÜV Süd, we provide service for EV batteries in mostly for R&D testing, but also ESS batteries, where we do performance, durability, and safety tests, and focusing on certification and global market access. Also, EU battery regulation is one of our key capabilities to help customers, and also the people who put the battery in market, to help entering the European market. TÜV Süd battery testing is represented all over the globe. We have 12 laboratories globally. Here in China, I am at the moment presenting from Zhengzhou, and another lab we have in Guangzhou, where we test large batteries. But wherever your market need is, let us know. And I'm happy to get in touch with you. You can contact me by email. You can find me on LinkedIn, or also through Vivian Nicole, can help to find me. Thank you very much for your attention, and I hope you can take out some learnings from today's presentation. Thank you.
Thank you, Marco.
Okay, thanks very much, Marco. Yeah. Okay, today we have another veteran, Kyle Song from CSA Group, a company expertised in standards, testing, inspection, and certification. Okay, welcome, Kyle.
Thank you, Nicole. Can you see my screen? Can you see my screen?
Yes, we can.
Okay. So today I
Yes.
will have a brief introduction to CAC Smart Grid System Certification Solution. So maybe as Eric and Vivian mentioned, and the introduction to their product is one of the key and critical equipment within a smart grid system. So I will have a brief introduction to CAC solutions. So let me introduce our CAC company briefly. So CAC Group is a global organization dedicated to safety, social good, and sustainability. So we are a leader in the North American standard and in testing, inspection, and certification around the world. CAC Group is composed of two organizations, standards. We are a standard development organization and also the testing, inspection, and certification company. So we currently have a member is more than 10,000, and we have 1,000 active standard committees. So back to our today's topic, the certification solution to smart grid system. So the smart grid is a complex system that utilizes various technologies to improve the efficiency and the reliability of the power grid. Generally, the smart grid may be composed of the distributed energy resources, the power conversion equipment, smart meters, and the energy management system, and also the communication means. So CAC offer certification services to critical equipment in the smart grid system, like the equipment mentioned in this slides for both residential use and also commercial use. So let me introduce in detail. So we can, for a typical PV system, the PV modules are certified according to PV series, PV system component. We have PV junction box, PV connector, PV cable, PV combiner box, and also the PV arc fault detector system. We can provide the certification and the testing for various components. And this is the CAC safety mark. So C stands for the Canadian mark, and the US stands for the USA mark. For the performance and bankability requirement, the applicable standard are IEC 61853 and the CAC 450. So a lot of the PV plant manufacturer or vendor, they have the requirement for the bankability requirement. And for the power conversion equipment, such as the PV inverter and also the power conversion equipment, PV inverter means the inputs are PV array, and the power conversion equipment, which the inputs are battery energy storage system. The applicable standard is CAC number 107.1. And for the US market, we use UL 1741, edition 3, which includes supplementary A requirement and also supplementary B requirement. CAC also adopts the IEC 62109-1 and -2. The UL also adopts UL 609-1 standard to provide the certification to the inverter. So for inverter and the PCE, some regions also requires the efficiency listing. For example, California, they have a CEC efficiency listing. And the applicable testing procedure is CEC-300 and with the modification of Sandia testing protocol. And for PV inverter, a lot of protection functions relies on the software or firmware. So in this case, the functional safety requirement is mandatory according to the safety standards. For example, the installation monitor interruption function, arc fault circuit disruptor or detector. The PV rapid shutdown system equipment are one of the functions embedded into the PV inverter. So these functions shall meet the functional safety standard, such as CAC number 0.8 or UL 1998, UL 991. And we can also have another approach to use the CAC 60730-1 and the UL 60730-1 standard to evaluate these protection functions. Conversion equipment export the power to the utilities. And for each state, there is a specific state regulation to the equipment connected to the grid. For example, in California, we use the California Rule 21, and for Hawaii, we use the HECO connected equipment. In the past, back to 2016, the grid connected equipment should meet UL 1741 SA requirement. And now the latest version is in UL 1741 edition 3, there is a requirement of supplementary B, which refer to the latest version of IEEE 1547 and 1547.1. So these requirements are much more complex and which leads to testing more time and more time-consuming testing in these standards. And in California, there is a specific requirement to the communication. The communication protocol shall meet the CSIP and IEEE 2030.5. And also the inverter shall also be controlled or regulated by the utility company by the interoperability test according to IEEE 1547.1. And the microgrid application is a hot topic recent years. So a microgrid controller can transfer the inverter from the grid high mode to off-grid mode. For a typical residential application, the microgrid interconnection device is installed in the panel board. So the traditional panel board becomes a smart panel board, even have the energy management system, and also the transfer switch function embedded into the panel board. So in this case, the smart panel board becomes a critical component, and a lot of applicable standard and functions standard it will be used to evaluate this smart inverter, a smart panel board. So now we back to the battery energy storage system, as energy source is also a critical system within a smart grid system. For each component, the battery cell shall meet UL 1973 Annex E. And for battery module or battery pack or battery rack shall meet UL 1973, and also the BMS, battery management system, inside of the battery modules or battery rack shall meet CAC number 340. And the battery BMS also has the software or firmware to protect the temperature, over temperature or low temperature function. So this function shall also meet a functional safety standard according to 60730-1. And for the battery energy storage system, we use UL 9540 and UL 9540A standard to evaluate the large scale battery energy storage systems. And there is a new requirement like the large scale fire test based on the local regulation to evaluate the performance of the under the fire condition of the container. So a lot of new requirement based on the hazard in the field. A lot of standard development organization are on the convey the expert to develop the new standards. So this slide introduced the ER 9548 standard. This is another topic for the energy storage system. Different from the traditional safety evaluation, the test procedure is divided into 4 levels to evaluate the thermal runaway performance. For the cell level, we will focus on the thermal runaway and in our lab. And the module level, we will focus on the heat release rate and gas composition and also the smoke release rate. And in the unit level, we will additionally focus on the framing outside the battery energy storage system and also the heat flux on the walls, on the enclosure of the BESS. And also we will detect and evaluate the smoke release rate. In the installation level, we will more focus on the fire suppression system detection and alarm system. So that with more and more EVs running on the road, there is a huge amount of the needs for the electrical vehicle supply equipment as the critical infrastructure. So the EV charger, also known as electrical vehicle supply equipment, can be categorized as AC charger and DC charger. For the AC charger, the charging method is AC level 1 and AC level 2 with different nominal supply voltage and maximum current limitation. For AC level 1, the voltage is 120 volts with 12 amps or 16 amps, which is connected to the standard American home outlet, 15 amps or 20 amps. So it will take a longer time, generate 8 to 10 hours to fully charge an electrical vehicle. The applicable standard is this is a traditional standard used for Mexico, Canada, and the USA. Yeah. For AC level 2, the applicable voltage, the applicable voltage is 208 and 240 volts, one phase, 80 amps maximum output, which connected to the American branch circuit breaker rating is 40 amps, 50 amps, and 60 amps. Generally, it will be the EV will be parked at a home, workplace, and shopping malls. So the AC level 2 charger will generate is wall mounted or pole mounted with or without a plug. Yes, the applicable standard is just the same as AC level 1, is CAC number 280 and UL 2594 standard. Now, for the DC charger, the charging method is DC level 1 and level 2. A hot topic for the DC charger vehicle to load application, also known as the V2X application. So not only the safety standard shall be met, and also if the charger can export the power to a grid, it just functions as an inverter. So it also meets all the grid requirement as mentioned in the inverter section. And the efficiency of the EV charger is governed by the Energy Star program. So, and there is the minimum power loss requirement for both AC charger and DC charger. And as the As the EV charger becomes a component within the smart grid, the EV charger shall also communicate with various parties, such as the communication with grid, communication with operator, and also communication with the electrical vehicle. So an EV charger has a complex communication system and should meet various communication protocols. For example, the communication with EVSE should communication with EV, and the both EV and EVSE shall meet ISO 17118 series standards. Next slide is the brief introduction to our CSA Queensland lab. It is established in 2012, and we are accredited. We moved to a new location, and this is our new site picture. We have already accredited by SCC, OSHA, RAS, IEC, accreditation bodies, and we can provide the energy power related products such as PV panel, inverter component, and also energy storage products like battery energy storage, electrical vehicle supply equipment, and we also cover hard location and also industrial component testing capabilities. So that's about the smart grid applications in for various critical components. If any questions, then you can leave your message or you can email to me. Yeah. Thank you.
Thank you very much.
Okay, thanks, Kyle. Yeah. I think we run out the time a little bit. Now let's come to the QA round. I think our audiences send some questions in the chat box. Some questions are already answered in here in the chat box. So here there is a new question. Are there any special installation requirements for the integrated smart energy system? Okay, I think this is for Eric.
Yes. So just as I mentioned to you, our installation method is very special. But this kind of special installation will have will be more quick and more stable and more have better reliability. We'll use some clip to instead of the traditional clamp and bolts to finish the installation. Okay.
Okay. Okay, it seems there is no more questions. Okay, thanks everyone. We appreciate our speakers to share the insights and the knowledge. Thanks to Eric, Kyle, Marco, and Vivian, and our audiences for your participation. It is an inspiring and insightful discussion. And please stay tuned for our future webinars. We would like to share, connect, and build the industry network and the platform with all experts to have genuine and thoughtful dialogues. I think we can round up our webinar today. Thank you.
Thank you.
Thank you very much.
Thank you all.
Thank you. Goodbye. Goodbye.
Bye.
Bye.